look at LeetCode 1. This is the two-sum problem. And I'm going to show you guys two ways that we could solve this, right? Which is the brute force solution and how we can use a hash map. So if we look at the problem, it says, given an array of integer nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution. You may not use the same element twice. So if we look at the example that they've given us, where we have an array and the target, and then you look at the target, so it's basically the target is 9, right? So something plus something is going to give us 9. And in this case, it's index 0, which is 2 and 7. So these added together give us target 9. When you take a look at the problem, you have to ask yourself, well, what are they asking for? Right? And as I've explained before, what they're asking us to do, right, is we're basically going to check which of these added together is going to give us this target, right? So basically they want us to go, well, this and this, does it give us that? In this case, yes, but imagine if the 7 was much further along, right? So this plus this, 2 plus 11, 2 plus 15. And then we go 7 plus 11, 7 plus 15. And the last one would be 11 plus 15, right? Because we're trying to figure out which of these two elements in our array give us our target, which is 9, and then we return the indices of those. Look, here it's quite easy to see, right, that it's going to be 0 and 1, but obviously we have to do this programmatically. And when you look at a problem like this, I would imagine for many people, including myself, the first solution you think of is, well, I'm just going to loop through. And the way you could do it is you could have two loops, right? So you would start at, so what you would do is you'd have two loops. So imagine it would be for I in range, the length of your array. And then you would have J, right? So J would be at the next index, right? Because remember they said that you can't have the same element twice, right? So we can't start at I here. You can't have J here because it would be the same. So we have to start here. That way we go, okay, well, I is 2, J is going to go here. So 2 plus 7, 2 plus 11, 2 plus 15. If we don't find the pair that gives us the target, then what we simply do is we go, well, we didn't find it, so we go to the next one, right? And then that comes here, because remember, J is actually I plus 1, right? J is I plus 1. Now I'm going to take us back to LeetCode so I can show you what the code for this would look like. And now we're going to be implementing our brute force solution. So in this case, we're just going to use two for loops to check if two elements at certain indices actually equal our target. So for I in range, so it's the length of our array, which is nums. And then we'll have a second loop for J in range. So remember, with the second loop, right, we want to start at the next element after I. So if we come back to the example, so if 2 is at index 0, that means we want to start at index 1, right? So we'd go, J would go 1, 2, 3, whereas I is going 1, 2, 3, 4, right? So J is always one step ahead. This way, they're never at the same element at the same time. Okay, so we go for J in range, so we go I plus 1, and then the entire array, which is nums. And so then we will take the element at I and the element at J and add them together. And then we're going to use that sum to compare if our sum is equal to the target sum. Because if they are equal, that means that we found the elements or the indices where it's equal to target. So we go nums I plus nums J. We look if sum is equal to target, right? So if this is true, which means we've met the condition for us to be able to return, will return I and j. Run our code to see if it's going to pass the tests. So it has been accepted, right? But if we submit it, because remember I had said the problem with this solution is that it's not efficient. In this case, it works, especially because we have such a small array. But in actuality, the time complexity isn't really good, right? Because it's big O of n squared. Let me just try to remember where do we check complexity again? Yeah, analyze complexity. So if you look at that, big O of n squared, we can do better than this. So now I'm going to show you guys how you would use a hash map. I already showed you guys the brute force solution of how we can solve the problem. Look, the solution worked, right? But the issue was that it wasn't very efficient. And in code, you definitely want to try and be as efficient as you can. And one of the ways, at least for this problem, we can use a hash map. So the way that we're going to use the hash map is we're basically going to use this little equation here, right? Because we already have a known number. A known number in this case, I mean the numbers in our array, right? This is what I mean when I say a known number, right? We know that it's the known number plus x gives us 9. Right, so what do I mean by that? So for example, the known number here, if we start at index 0, right, this is index 0. Well, the known number at index 0 is 2. So we know that 2 plus something, right, we don't know what the something is yet, is going to give us 9. And if you look at this, right, especially if you've done math, you know that, well, I mean, the way we figure out x is we take this 2 and we move it to the other side, right, making it a negative. So 9 minus 2 is what? Well, that gives us 7. So 2 plus 7 is what is going to give us the target. So the way we do this, right, is that we go, well, if we go to our hash map, right, represented by a table here, do we have a 7 in our table? No, we don't. And so what we do is we're going to save the value at the index, not the actual 7, right? We don't save the 7. This is what we save. We go, okay, well, we're going to put 2 here, and then the index, which was at 0. And the reason why we're saving the numbers in our hash map, our table, is because we're going to be looking up values to check if we've already seen them. And then we go to the next one, which is index 1. Well, what's the known number at index 1? The known number is 15. Right, so 15 plus x is going to give us 9. And again, we're going to move 15 to the other side. So 15 comes here, becomes a negative 15. So 9 minus 15 is negative 6. And then we go back to the table, right? We go, well, if we look at the table, do we have a value 9 here? No, we don't. So then we're going to save not 9, right? We don't save the answer that we work out. We go to the table and we go, okay, we don't have a 9. So then we put 15 in here as a value at index 1. And we do the same thing for the next one, right? So we're not going to be iterating multiple times, because that was part of the problem, isn't it? Because we'd have to go like this. In the brute force solution, we'd iterate there, and then we come back here, and then we do that, and then we do that, and then we come here. You can imagine, look, this is a really short array, but imagine if it had, I don't know, like millions of elements, right? That's going to take a lot of time. And if you know anything about exponential time or just exponential anything, right, is that it grows exponentially, which it goes from like bigger and bigger and then incredibly big, which is not what we want. Okay, so then we go, well, we've done 15, so we go to index 2. Okay, I'm just going to remove some of these. I think they're a little, and then we go to index 2, right? So index 2 is what? It's 11, and it's the same thing. We go, well, 11 plus x gives us 9. We're going to move the 11 to the other side, which is going to make it negative. So then we go, well, what's 9 minus 11? That gives us negative 2, right? So we go x gives us negative 2. And then we go back to our hash map and we check, do we have the value negative 2 here? No, we do not. So again, we don't save the value that we calculated. We go to the element in our table. We go, well, 11 comes to our hash map. And then we're going to save its index, which was 2. And then we go to the last one, right? Same logic. So we'll just go 9 minus 7. 9 minus 7 gives us what? It's going to give us 2. So 9 minus 7 is 2. We go to our table. Well, do we have a 2 in our table? Yes, actually, we have a 2 right here. And so now we know that we have to return 0 and 3. So we're again back on LeetCode, and now we're going to implement the actual solution. So I've just commented out the brute force solution. Okay, so we're going to create a hash map, right? Because this is our table, right? Think of your hash map as your table where we're going to store values that we've already seen. And then we're going to go, so we are going to have a for loop, but in this case, it's just one for loop, right? So we go for I, so the index num. So in this case, we're just going to use enumerate, because what do we need? We need the index and we need the actual value, right? So for I num in enumerate the list, which is nums, we're going to go, well, the complement is equal to the target minus num. So this is the same thing we had, which was no number, right? X target, just the naming has changed, but the logic isn't, right? Because target is what? Target is 9. Num, right? Num is going to be the number at that index. So it could be 2, 9 minus 2, right? So don't be confused by the naming. So if the complement, so the complement is the answer that we get. If the complement in our hash, if the complement is found in our hash map, then we're going to return hash map complement and I, right? It's not in the hash map, so we haven't found it yet. Then we go, look, well, in our hash map, we're going to add. So this is, we add the value and then we add the index. It's exactly the same logic that I just took you guys through, right? So I'm just going to go through it over one more time. So we go target, which is 9, minus known number, right? So it could be 2, so 9 minus 2. The complement is the answer, which is 9 minus 2 is 7. So it would look like this, actually. It'd be 7, 9 minus 2, right? It's literally just that. And then we go, well, if the complement, so if 7 is in the hash map, again, visualize the table. If 7 is in the hash map, then we know that we're going to return where 7 is in our table and then the current index we're at, right? So in this case, we know that 7 is at index 1, and then currently we're at the first index. Yeah, so then we return the 2 indices that we need. In this case, it's 0 and 1. If we don't find, right, so if we're not able to execute this, so it's not true because it's not in the hash map, then we want to add it to our hash map, right? Because remember, it's a lookup. We go, is this in our table? It's not in our table, well, then put it in our table. Is this part of our, and then we go to the next one. Is this part of our table? It's not part of our table, then put it in our table until we find where we have a complement that's in our table, which means we found the pair that we return. So if I run this, okay, I forgot to remove this. That was very silly. But yeah, so if I run this, there you go. Okay, I'm going to submit it because more than anything, I just want you guys to see the time complexity. Okay, and then we're going to analyze this. Okay, so it turns out I reached my daily limit. But if you guys give it time and you analyze it, you'll see that it's now big O of n. Okay, as always, do practice this.